We have a herd of 20 deers introduced to an island where there had been no deer before. Then the population of deer is predicted to increase so that after a period of 10 years, the population is this big S function. So we have this one where the D is the population of deer, K is a constant. Remember that we have a differentiation between the variable and constant. Okay, so D is a variable, K is a constant, 1 plus 4E negative 0.14T. Okay, so this is the function or the equation for population of deer D. Okay, show that K equals to 100. So how do we show? What clue do we have? If you read the question, is there any number given, any clue given? 20, right? So the 20 is actually the initial population. The population at the beginning is 20 deers. Okay, 20 deers. So when P equals to 0, D equals to 20. So we have this information from the question. Okay, then we can sub in to find our K. So 20 is equals to K over 1 plus 4E to the power of 0. Okay, E to the power of 0 is 1. So this is 1. So 20 is equals to K over 5. So K equals to 100. Part 1. Okay? Okay, part B. So find the number of deer present after 10 years. Give your answer correct to the nearest integer. Okay, so after 10 years, after knowing the value of K, we can find. Okay, so D, okay, when T is equals to 10, after 10 years, D is equals to 100 over 1 plus 4E negative 0.14 times 1 times 10. You can put the 10 over here. Okay, so someone with calculator can help. Okay, so what does the calculator say? Again, sorry. 50.3426. Okay, so roughly 50 deer. Okay, 50 deers. Nearest integer. Okay, so part C is the one that I want to talk about. Okay, part C is the one that I want to talk about. So let's take a look at part C. Now find the value of D when T become very large. So meaning, right, as time passes by, what is the population of the deer? Okay, as time passes by. It decrease, increase, decrease. Technically it should increase, I think. It should increase, right, from 20 deer increase to 50 deer. So it should increase, but how does it increase? We need to see. Okay, so how do we do this? Okay, so very important. So this is a higher, supposedly a higher order question. Supposedly it is a tough question, but it has come out very often such that it doesn't become higher order anymore. Okay, so how do we analyze this? We need to focus on this whole formula. And we need to start from this. Okay, we need to start from this. Okay, one more time. We need to look at the whole formula. Most of the time, we'll need to start with the exponential function. Okay, so if we start from this, so as t becomes very large, so as t becomes very large, mathematicians, we use symbols to express words. So as t becomes very large, we start with the exponential function. So e to the power of negative 0.14t. What is the behavior of this graph? So if you remember, e to the power of x, the graph will go upwards, exponentially upwards. E to the power of negative x, the graph will go exponentially downwards. Correct? So as time passes by, if the t becomes very large, what happens to this value? The value becomes closer and closer to what value? 0. The y value becomes closer to 0. So this one becomes closer to 0. Okay? And then we'll do things like what we do for the inequality. We have a times 4. So 4e to the power of this thing will approach 0. Then we plus 1 on both sides. So 1 plus 4 of this will be 1. Plus 1 on both sides. Okay? Then afterwards, what do we do next? The whole function flip, right? So we flip the function. So 1 over this thing would also, so 1 over this on one side, 1 over 1 on the other side will also go to 1. Okay? Okay, if we flip to become a fraction, on the right hand side we should also flip to make it a fraction. Last step, we need to multiply by the 100. So we times 100 on the left. Then we also times 100 on the right. Okay, so the population of the deer would approach 100 as time passes by. Okay, so this is how we do this kind of question. Okay, so there is always the inequality question, there is always the approaching question. Okay, so two kinds of part C, part D kind of question. The first kind is inequality question. The second kind would be approaching question. Okay, can So depending on what is the instruction, then we need to find the specific thing. So find the value of D as t becomes very large, so we need to start with this. Then it will be an arrow kind of working. Yep. Because this one is a fraction, I want to convert it back to this. Yeah, so 1 over 1 lor, so it's also 1 lor. If this is 2, then this will be 1 over 2. Okay, get it? Can Yeah. No, the number of? No, it will approach 100 as time passes by. You will not go past 100. Yeah. Okay. Now, let me show you a second variation. Okay, what if the question changed the tune and they ask, instead of asking like this, okay, show that D is less than 100 for all, less than or equal to 100 for all values of T. Okay? Just flip lor, 1 divided by 1. 1 divided by this, right? So this is 1 divided by this lor. If this is 2, then this is 1 over 2. If this is 2, when you flip, it's 1 over 2 lah, correct? Because this side you fraction yeah, like that. Okay, can. Okay, this one. So how do we show? Let's say if we want an inequality, same thing. We always start with this. So for all the exponential function, it is always a positive number, right? Because if you observe the graph, the exponential function, the values are all positive. Okay. Then we do the same thing. 4, right? So 4 times this. Same thing is the exact same thing. 1 plus 4 of this. Right? We flip also, but when we flip, be careful. Yes. When we flip, be careful of this inequality. Then we multiply by 100 on both sides. Okay, can So one more time So there are usually two kinds of working or two kinds of approaches depending on how the question asks. So the first kind of approach is as t become very large, then your working need to follow the arrow. Okay, as t becomes very large, this becomes 0, this one is 0, this one become 1, this one become 1, this one become 100. So this becomes something. Okay, but over here, right, if they ask for an inequality, then we need to start with an inequality over here as well. Okay, so this is more than 0, this one more than 0, so play with the inequality. The working is similar, it's just that the symbols that we use a bit different. The sentence that we use a bit different, but it's only that slight difference. So let's do this. Question 8. So what is our relationship over here? It is a relationship between temperature and time. Okay, temperature T and the time small t. Big T and small t, so be careful. The K over here, I didn't put a color because the K is a constant. It is a number that we need to determine. Okay? One more time, Yay. Okay, so one more time. You have to differentiate between the variable unknown versus the constant unknown. Okay, so for constants, we usually need to find these constants, and then the one that is always changing is the big T and the small t. Okay, let's start. So given this equation, given that the temperature of the cup was 45 after 1 hour, show that K equals to 0.470. So when after 1 hour, when T equals to 1, T is in hours, right? Double check. Okay, then the temperature is 45 degrees. So we try to solve for K. So 45 is equals to 35 plus 16e to the power of negative K times 1. Okay, so let's solve for K. Minus 35. So this is 10 over 16, 5 over 8 is equals to e to the power negative K. Get rid of the base e, so I have a ln 5 over 8 is equals to negative K. So K equals to negative 5 over negative ln 5 over 8. Why got negative number? Oh yes, it should be a negative number, correct? Because, okay, so what is this? Calculator? Is it 0 point something? 470 what? A bit more. We need to show, right? So 0.470 470,004. Okay, so roughly 0.470 to 3 as F. Okay, so must show the approximation, must show all the working. Okay, so here we are looking at question B, and question B we need to find the number of hours needed for the coffee to cool to at least 38 degrees. So the thing is, right, we are looking for the coffee to cool to at least 38. So the inequality that we need to set up is T is more than or equal to 38 degrees Celsius. So the T, we're going to replace T with what we found out just now, which is to put this into the T. So 35 plus 16 e to the power of negative 0.47004 T. And this thing must be more than 38. Alright, so let us try to solve for T. Right, so it's just reverse process, and we want to make T the subject of the inequality. Okay, so we just minus 35 on both sides. And then we divide by 16. We will divide by 16 to get a 3 over 16. And then we will need to take the ln of both sides, alright? So base e, right? So we will need to remove the e. So e is base e, we have 0.4. So we remove the base on the left. And the reverse process on the right hand side is to include a log base e, or ln of
3 over 16. So now, because we are dividing by a negative number, so t is going to be less than, because we divide by negative number, so we need to flip the inequality sign. So t would be less than ln 3 over 16. So this number divide by negative 0.470004 t, and t is less than 3.5617. Okay, so over here, the thing is that because we want to be at least 38 degrees, right? So anything after 3.5 minutes, anything after 3.5 hours will be below 38 degrees, right? And for it to be above 38 degrees, we will need the t to be roughly 3 hours. So the answer would be 3 hours. Okay, if it's 4 hours, it'll be below 38 degrees. If it's 3 hours, it'll be above 33 degrees. Okay, so I'm going to write here, if t equals to 4, the temperature is less than 38 already. No longer at least. Okay, no longer at least 38 degrees. Right, a bit sad. Okay, so this is part B.
Part C, what do you think will be the lowest temperature of the coffee? Explain your answer. Okay, so this one, the lowest temperature, because it's a cooling thing, we need to let it cool forever. So we try. Okay, so this one, when or as time goes to infinity, what happens? So where do we start first again? We start from the exponential function. So e to the power of negative 0.470 t will approach where? If t becomes very big, e to the power of a negative big number will become, again, will become very small, become 0, correct? Become very, very small. Okay? Then we need to build back the equation. So times 16 on the left and the right. So I times 16 on the left, I times 16 on the right. I add 35 on the left and right. So 35 plus 16 and this. So I add 35 on the right. So on the left is big T, on the right is 35. So the temperature will approach 35 degrees. Okay, so technically speaking, the lowest temperature will be 35 degrees Celsius.